Good morning, good afternoon, and good evening, everybody. Thanks for joining us for another Cassandra.Lunch, Cassandra.Lunch 133 to be exact. My name is Akwi Ohiri. I'll be your host this afternoon. This afternoon, we have a returning guest here at our Cassandra.Lunch, Dipan Shah. We're going to be going over vector search with Apache Cassandra. We're excited to get into this. The hosts for this event are Raul and myself. We are looking for speakers and sponsors for this event. If you're interested in either opportunity, please reach out to me at my email address listed below. We are a part of a larger community called Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome, and we expect respect to be given to all. Data Community DC is made up of a lot of different groups, all generally surrounding data. You can find out more about these groups at the listed links below. So what do we cover here at our Apache Cassandra.Lunch? We cover everything related to Apache Cassandra, Kafka, Spark, and everything in between. If it's your first time joining us here at our Cassandra.Lunch, please go ahead and introduce yourself in the chat, how you work with Cassandra, how you found this group maybe, and what you're hoping to learn. Group rules, if you have a question, ask it. Be polite and courteous to others, as I mentioned earlier. And we do want this to be inclusive, so please do share what you know with us on the topic. Here at Anant, we design, build, and manage global real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. So I guess you could say Cassandra is our bread and butter. We'd like to thank our program sponsors and also our organizational sponsors for their continued support. 15-second announcements. If you have any jobs, meetups, hackathons, conferences, or classes coming up, please go ahead and drop a link to those in the chat along with a short description and what our viewers and listeners can expect. Cassandra events. Obviously, we have our Cassandra.Lunch every Thursdays, our data engineers lunch every Monday, both at 12 p.m. Eastern. We may not have our data engineers lunch this coming week due to the national holiday here in the US for Independence Day. So please make sure you're subscribed to our meetups, and also you can check out our Anant.us/events page as well, so you stay updated regarding upcoming events. We do have an LLM bootcamp that kickstarted last week. If you weren't able to join us for session 1, please do go ahead and subscribe for the 4 remaining sessions. There's still a lot of knowledge out there. That's going to be listed on our website as well on the events page. Also like to point you to our channel. If it's your first time joining us, please go ahead and subscribe to the channel. You get notified every time we go live, so you don't miss any videos. And obviously you can watch videos on demand at your convenience. And then finally, like to point you guys to Cassandra.Link. Your one-stop shop for all things related to Apache Cassandra. Please do check that out. The site has undergone a revamp recently, so check it out, share some resources, give us some feedback. And finally, our latest runbook focusing on using Terraform and Ansible to install Cassandra on AWS and Azure is still available. Please go grab your copy while it's still available. I'll be leaving a link to that in the chat as well. And with that, I'll be handing it over to our speaker for this afternoon, Dipan. Dipan, over to you.
Thanks, Aki, for the introduction. Hello, everyone. Today we're going to talk about vector search in Apache Cassandra, right? So I'll just quickly share my screen. Aki, can you confirm if it's visible?
Yeah, we can see your screen.
Right. So yeah, today we are going to talk about vector search with Apache Cassandra. This is a new functionality that is coming up, and it is a functionality that has generated a lot of interest too. So people are interested in with all the advent in ChatGPT and all the AI stuff happening. People are interested in vector databases, vector search, and all. And the good thing is that all of this is getting incorporated with Apache Cassandra also. So we're going to talk about this. I'll explain a bit about what is vector, what is a vector, what is vector search, and how all of that works in the background. Eventually, we'll also have a demo on how you can use vector search with Apache Cassandra. And I'm also going to try to do a short demo on how vector search is getting incorporated into data like Astra too. Right. So let's get started. Yeah. So This is for like beginners who want to actually understand how all of this thing, how all of these things work in the background, right? So what is a vector? Now, a vector is just a data structure, a type of data can represent words or images or audio also. And right. Okay, is my audio still like fine? I'm sorry, I just received. Okay. But I'll assume everything is working fine. Okay, so I'll start from scratch, right? So vector is just a data structure, which is represented as a numerical array. And what you do is you have your words or audio files or even images in some cases. All of that goes through an algorithm, right? How you know token ranges and all of those things work in Cassandra. You have an algorithm or a generator that actually takes words and converts it into arrays like the way it is shown on the slide, right? Now, these multi-dimensional arrays, you can think of them like you have this graph on the right-hand side, right? So this is how it is. You can, for interpretation purposes, this is how you can think what a vector looks like. If you try to look at it in the database, it is going to look like this array that is represented on the screen. Now, a vector database is nothing but just something that is optimized for storing these kind of data points, so these kind of data structures. And what it is really good at is that it clusters all of these numbers on the basis of their similarity. Okay, so for example, you have two words that are similar. So it could be, say, a puppy and a dog. Okay, so if you search for dog, you have something like if you think that puppy is also a similar word. So the arrays or the vectors for these particular words would be similar. They're not exactly the same, but they are similar. And that is how these vector databases cluster all of this data. So it gets stored on the basis of similarity, right? And then you also have indexes on top of these data structures, which are used by these databases for quick retrieval of your data, right? And we look at the image below. This is like basically just explaining how we take audio or text. It goes through a model and gets converted into vectors, right? And like the vector that you saw over here is it'll get converted into vectors like this, and that can get stored inside a vector database, right? And then eventually we have vector similarity search, right? So what is a vector similarity search? The example that I gave earlier, right? When you have a dog or a cat, and then you also have a kitten with it. So when you query for, say, cat, you want results related to kitten also. So this is not an exact search. This is not something that you would do in your relational database when you say that select star from this where this column is equal to cat. Then you'll only get something that is related to cat or has CAT in the text somewhere. But the way a vector database stores this data, you can basically get related information that is stored together, and you can search on the basis of that. So over here, you could basically search for fruit also, and it'll give you either apple or banana. And in some cases, that apple might get a similarity search with Apple and Google also. So, but that is not something we're going to cover today. The models work in a different way. But as a very at a very simple level, we just need to understand that a vector is just a data structure. You have your text that goes through a model, gets converted into these vectors, and eventually on the basis of the similarity gets stored together. Okay. So that is how vector similarity search works. Now, in today's demo, we are going to use Cass.io, right? So what is this? This is a Python library, which when you use with Cassandra, right, it actually solves your problem of all of these models that you have in between and how Cassandra by default, you don't have vector search capabilities in it right now, right? But then when all of those get added, you can use this Python library and use this for say artificial intelligence, machine learning workflows, and you simply basically just use it in your code. Try to use it for approximate neighbor search, and then it will go and show you the data. I'm going to give you a demo about this, so that will explain it a bit better. But then this is what Cassandra does. It enables you to do all of these searches, right? With this information out of the way, we are going to do this demo. Now, the demo is basically not with the Apache Cassandra that is already like generally available, because they are not yet included in the distributions of Cassandra, but there is a branch where all of this code is already there. We're going to use that. We have to build that version, and then we'll start using it for this search purposes, right? Quickly bring up my server. Here. Right. Okay, so let's get started. As mentioned earlier, like, this is a blank server that I have. There's nothing over there. So if you are trying, if you have a blank server, this is an Ubuntu server, you can follow the exact same steps. We'll publish a blog post of this with the detailed steps over here, so that you can also follow once you have that information. So first, what we're going to do is we're going to clone the latest Cassandra that we have, right? So I'll also open up another window where I can basically take care of the other requirements too. How we need Java and all of these things. Yeah, one more note, you will have to use Java 11 for this. And that is supported right now. Let Java get installed. We have this available here. Let's go inside the Cassandra directory. So, all right, we downloaded the code. And the checkout branch. Let's just see if we have everything. All right. Okay. We set up the environment variables. We will use this. Java has been set up. Great. We'll also need Ant for building this Cassandra code that we have. This is just setting up Cassandra in general. So once all of these features are generally available, the way you install Cassandra, you just follow the same steps and start using it. But we just have to follow this for now. And again, this building can also take 3 or 4 minutes. So in the meantime, we take care of other stuff, right? I'll also need a special version of SQL.sh, which is vector capable. So I just downloaded that. We unlock this. Right. So we have Cassandra, we have SQL.sh. Right. We'll also make a directory for the log files so that we can get started. It's possible. Right. One more dependency that we have is I'm also going to show you how this works on the SQL shell. But at the same time, we also want to look at how this is going to work from, say, some Python code also. So we'll just take care of installing these drivers too. Just installing the Cassandra driver now. Just done. And this might feel like a lot of steps right now, but again, as I mentioned, you can simply follow the same steps that you do for the Cassandra installation. Just think of it, it's happening the same way. It's just that we are building the Cassandra code because we want to test the vector search capabilities. Yeah, and again, as for questions, like as Akri mentioned, you can drop them in the chat whenever, and we will take them up. I think we should be done in now. All right. Yeah, so it took about 4 minutes to do this. Quickly clear out my screen. Yeah, great. So we are going to run this as a single node cluster right now. So there's nothing else that we need to do besides just starting up Cassandra, right? We started directly from here. We come up with the default settings. There's nothing else that's required right now. Right, 5, 3, that's it like that. Let's just go into SQL SH. Not yet. Let's start a complete. Yeah, great. We're connected. Right. So we're using Cassandra 4 and we are connected. We just describe key spaces. We just have the default key spaces for now. There's nothing else. Okay. So the first step is we just create a basic key space with a simple strategy replication factor of 1. We're just naming it research for now. We're going to use the example that DataStax has for Astra for this vector search. So we'll just use the same example over here. Create that key space, right key spaces, and we have research. Okay. Now we create a table where we can store this vector data. And if you look at the schema, we have an ID that is integer, name and description that are text. And then we are storing a column named item vector, which is a vector, right? And we are mentioning 5 is the 5-dimensional element. So you can have multiple dimensions. take different values for these dimensions. So that is again that depends on how we are going to be storing and using the data, right? And once we have this, we also need an index on top of it, right? Because in Cassandra, you can't just query this column straight away. So we're creating this index, right? Which is storage attached index. And that's it. Now let's insert some data into it. We have a couple of rows that I'm going to insert over here. If you look at my screen, they got inserted successfully. What you have is, you have your ID, you have your name, right? You have your description. At the same time, you also are storing this vector. Okay. Now keep this in mind. This vector calculation and all of that stuff, we are not doing that here. That has to go through that model. You have to collect this information and then store it in Cassandra. We're just adding a functionality in Cassandra where you can query vector-based data, right? You are not going to be able to generate that data from here. So whenever you insert this data, so if you're going to store a vector, you have to, when you insert your data, you say that, okay, my ID is 2, my name is this, my description is this, and the vector for that is this. You calculate that vector in your code, right? And then you come and store it over there. Once we have that, let's just select data from that table, right? And you can see your vector being stored over there. Okay. Now, how do you search this data, right? This data search happens on the basis of approximate neighbor search. It's the nearest neighbor, approximate nearest neighbor search. So what happens is, like in the example that I provided earlier about a cat or a puppy or a kitten or a dog, whatever, right? What you do is you say that, okay, I'm searching for a cat. If there's an exact match for a cat, you get it. But if there is a similar match, a nearest neighbor match for kitten also, it is going to show that also. So the query for that is going to look like this, where you say, select star from your table. You're ordering by item vector, that is fine. But with the approximate nearest neighbor search off, and then you mention a vector. Okay. Now, if you see over here, this vector does not have a direct match with any of these columns. You don't see 0.15 over here. You don't see 0.1 in the second position, whatever, right? But when you search for it, it is going to say that, okay, whatever this is a vector for, right? Say I'm searching for a deep learning model or something else. And then when I sent it through the model, it gave me this vector. So I came to Cassandra, told it that, okay, this is a vector that I'm searching for. Can you see if there's anything that you can correlate it with? And it will show you whatever it can find. That is the nearest neighbor for this thing. Right? So again, to specify, you don't generate this with Cassandra. This gets generated in your model. You store it in Cassandra and then you use it for query. Now, there are other vector databases outside that will also do this, right? And especially built for this purpose. The advantage of using Cassandra with this is that you have your inbuilt functionalities of Cassandra that are already in place, right? It is already good. It can take lots of data. It can grow exponentially. It can make your queries and all of them can scale pretty well. And then you also have an added functionality of vector search, where all of your machine learning workloads or artificial intelligence use cases can also be used pretty well with Apache Cassandra, right? So that is what we're doing with. Now, this is how we did it using SQL. Now let's do a similar thing using, say, right? So we already have our drivers installed over here, right? And just create a Python file over here. I have the code ready. Explain that a bit too. Right. So the same thing that we with SQL, we are trying to do a similar thing over here, where you're using these libraries, right? The key space node table names are defined over here. then this code can also create the same data that we did, but we don't need to worry about it, right? Because we already created that. If you're not created it, it will get created. And then what you do is you search for this data, right? So when you want to incorporate all of this into your code, it's as simple as this. There's nothing else that you need to do, right? We have this file. What I'm going to do is I'm just going to, right? It just says creating table and all of that, creating index. That is it. But at the end of the day, it gives you the nearest search that it could find for that particular vector also. Right. So the code example is also pretty simple. I'll actually not sure if this is visible pretty well or not, but I'll maybe just pull up my notes and show it to you. Right. So what we did was pretty simple, right? We cloned Cassandra, the latest version that we had. We got Java up and running. We just set up the environment variables, build the code that we had, got CQLSH, the vector capable version, right? Started Cassandra, started CQLSH, created our data, and searched for it, right? It was as simple as that. So this is how you can basically use it for vector search. And I'll also pull up an example of the same thing that you can do with Astra DB also. Just quickly go through it. There's not much that is different with Astra, right? Once you you log into Astra, right? This is the default screen that you get, and again you can have you can use this for free. So there's this page there's this banner that they have on the top of their welcome page right now, where it says try Astra with vector search. Okay, but it's still in public preview. This is not completely production ready. So it's still in public preview. And what you can do is click on interactive guide. It'll give you what vector search and all is, but you create your databases, right? Create your tables once you log into your SQL console, you create your table. You create the same table and indexes over here, right? The ones that we did. You insert the same data and you select it using this. You can play around with this with different data sets that you can obviously get online. That'll also help you learn a bit about it, but then it's pretty simple. And the only thing different that you'll have to do for Astra is that you'll have to bundle. So when you install this driver and all, what you have to do is because I was connecting using Python to a local Cassandra node, I did not, and my authentication was also not enabled. I did not have to do anything else, right? But what you can basically do is you can just create an access tokens from here, right? And also download the security bundle for your particular database that you create. So for example, I have this vector search DB over here. I'll create that database, download the connection bundle, mention the bundle details over here, right? You get secure connect bundle ID, Astra client ID, and the secret that you have. Just feed that over here, and then you again run this code, and it's going to give you the same output that we saw here. Right. So yeah, that's it for this demo. I think we've covered everything that we wanted to. Yeah, there's this link for Cassandra also, which you can basically look at. It explains how it has a good explanation about what are vector databases, what's vector search, how we're going to use this for line chain and all of that stuff. So all the different LLM frameworks that we have. So this is also a good page that you can read about, and it's going to give you some more information about it. Yeah, I think that's it from my side. I'll be back to you.